We're on problem 154. 154. They ask us, is x negative? So the question is x less than 0? Statement number 1 tells us, let's see, they say x to the third times 1 minus x squared is less than 0. And let's simplify. Let's say x to the third minus x to the fifth is less than 0. Let's see, we could add x to the fifth to both sides. X to the third is less than x to the fifth. Let's divide both sides by x squared, and that won't change the inequality since x squared is definitely going to be positive. Any integer squared, even if it's negative, is positive. So you divide both sides by x squared, you get x is less than x to the third. Now let's see, does this answer that question? Or let's see what x's would satisfy this condition. So this is definitely, if you think of, so x, we can already say that x cannot be equal to 0, right? Anything where this would have been an equality doesn't work. X can't be equal to 0. It can't be equal to 1, because 1 is equal to 1/3. And it can't be equal to -1. So we know that immediately. We know that for regular positive numbers, for numbers greater than 1, taking it to the third power is always going to be greater than the number itself. If you took 2 to the third power, that's greater than 2. 3 to the third power is greater than 3. 1.5 to the third power is greater than 1.5. So we know that this statement right here implies that x is greater than 1. And let's see, is there any negative? Is there a situation where x can be negative? Well, let's see. First of all, if x is between 0 and 1, if x is between 0 and 1, let's see, if you have 1/2, 1/2 is not less than 1/8, so it doesn't work between 0 and 1. But what if you went between what if x were between -1 and 0? Let's try an example. If you have -1/2 is less than -1/8. It's more negative, right? -1/2 is less than -1/8, right? And you could try that with any fraction, because when you take it to the third power, it becomes a smaller fraction, but it becomes a smaller negative fraction. So x will be less than it because it's more negative. So this is true. So right now this statement applies. If this is true, then x is either greater than 1 or it's between -1 and 0. And let's see, does it work if x is less than -1? -2. Is -2 less than -8? Nope. Right. So these are the only ranges where it works. This statement implies this, but this still isn't enough information to tell us whether x is less than 0. X could be greater than 1, which is definitely greater than 0, or x could be less than 0. So we don't know yet, just from statement 1. Statement 2 tells us x squared minus 1 is less than 0. So add 1 to both sides. That tells us that x squared is less than 1. So because something squared going to be less than 1? Well, it's going to have to be between -1. It's going to have to be between -1 and 1, right? It's essentially going to have to be a positive or a negative fraction less than 1. That's the only way that when you square it, you get a number less than 1, right? If it was greater than 1, you're definitely going to get a number greater than 1, and it's going to be positive either way. And if it's 1, it's going to be 1, and then 0 is in our range. So statement 2 tells us this, but it includes both positive and negative numbers, so it doesn't answer our question whether x is less than 0. But if we use both statements combined, right, what is the intersection? What is the overlap of this and this? Well, if x has to be between -1 and 1, and it has to be one of these, right, the only one that it overlaps with is this one. You cannot have x being greater than 1 and x being in this range. You can have x being in this range and x being in this range, since this is a subset of this. So this is actually the more restrictive, and so since we go to that actually tells us that x has to be negative. So both statements combined are sufficient to answer this question, but individually they're not. The last question, 155. Marcia's bucket can hold a maximum of how many liters of water? So we want to know the capacity of her bucket. The capacity of her bucket. Statement number 1 says, the bucket currently contains 9 liters of water. that's useless. We don't know how. I mean, that could be the bucket. 9 liters could be that. Or maybe 9 liters is the full capacity. That tells us nothing about what the capacity of the bucket is. If I told you I had a bite of the sandwich, that tells you nothing as far as how large of a sandwich I can eat. So statement 1 doesn't seem that useful. Statement 2, if 3 liters of water are added to the bucket when it is half full of water. So 1/2 times the capacity, right? When it's half full of water, you add 3 liters. So if 3 liters of water are added to the bucket when it is half full of water, the amount of water in the bucket will increase by 1/3. So that is equal to to increase something by 1/3. That is like multiplying it by 1 1/3, right? That's 1 1/3 times the capacity. That's what they're saying, right? Right. The amount of water in the bucket will increase by 1. So they're essentially saying if you started off with, you're going to have 1 1/3 times what you started off with, which was half your capacity. That makes sense? We say we're starting with half of our capacity, and we're adding 3 liters. And they're saying that will increase the amount we have by 1 1/3. Let me write that. Let's say we start with x, and we're adding 3 liters. They're saying that will equal 1 1/3, or 4/3 times x, right? This shows that x is increasing by 1/3. You could view this as 1 plus 1/3 times x. This is an increase of 1/3. And they tell us that our starting point is half of capacity. So that's where I get the 1/2 c. That's our starting point, plus 3 is equal to 4/3 times the starting point, or where we're adding water to. 1/2 times c. And we could easily solve for c here. So you get a 2, this cancels out, and then you get 1/2 c plus 3 is equal to 2/3 c. And let's see, we could subtract c from 1/2 c from both sides, and you get 3 is equal to 2/3 minus 1/2 c. And then you could just do that fraction, and you get c is equal to 3 over, what is this? 1/2. So if you do it over 6, 4 minus 3. So this is 1/6. So this turns into 1/6. So c is equal to 18. But anyway, you didn't have to do all that. You should just realize that as soon as you can write this algebraic equation down, it's a linear equation with one unknown, and that one unknown is what we're trying to solve for, you have enough information to solve the problem. So statement 2 alone is sufficient to solve this problem. And we're all done with data sufficiency. See y'all in the next section.